Hello there. I'm going to go over today's lesson. Today is Tuesday, the 21st, and this is for the enhanced class. So today we're going to be going over like a warm-up, but we also have a little bit of practice with rational numbers, putting them on a number line. And then we're going to talk about absolute value, which is part of your homework. One of your homework assignments is the integer worksheet that I passed out yesterday. And so some of those ask about absolute value, and we're kind of talking about like when do we use this stuff and see it in the real world. And absolute value is very relevant. Like we use it quite a bit in our thinking. We don't necessarily all say absolute value, but we think absolute value. So it's just kind of a way to develop how our brains think about certain things. Anyway, we've got a warm up right here. Let's start with that. Very quickly, and we're familiar with some of these decimal numbers, and like these first two right here, and how to write those as fractions. Those are very good memory fractions. Like memorize these two right here, but these two are not necessarily memory fractions. So we need to talk about how do we just change any decimal into a fraction form. And it's pretty easy because we have an example down here. Let's just ignore the negative sign. That's not a big deal. We're just going to have a negative fraction, that's all. So, but how do we change 7/100ths into a fraction? Well, we do it the same way we change 4/10ths into a fraction. The 4 is the numerator, and the tenths, the place value, is the denominator. That's it, 4/10ths. There's our fraction right there. Pretty easy. And then, of course, we can simplify 4 and 10 by dividing both of those by 2. So remember, when we simplify, we're just like saying, oh, I'm going to divide this by 2, make that number smaller, and I'm going to divide that by 2 as well. So 4 divided by 2 is 2, and 10 divided by 2 is 5. So our final answer is -2/5. So this decimal is the same as that fraction right there. So I'm going to give you a second just to see what you think about these. This is a mixed number, so this is pretty simple. We just have -1. That's our big whole number right there, and then only the decimal becomes a fraction. All right, pause this video right here, hit pause, write down your 4 answers, and then come back to us. Okay, I think we're back here, and here's our answers upside down right here. So how about I just write them right side up? So these two we're familiar with these pretty well. So 0.5 is 1/2. And 0.25 is 1/4. And then we have a negative sign, we'll just keep that, and this is 7/100. The place value is 100, so that's our decimal. Oh, look at that. Oh, there we go. And then here we have -1 and the fraction, that's the fraction part. So that is 8/10, which is 4/5. So 8/10 becomes 4/5. It's not very good writing, but anyway, that's what it is. All right, here is a quick check that we're going to do in class, and you can do this as well. On page 75 here, work these problems out. It's pretty quick, pretty simple, where we're just looking at a number line here, and you're saying, okay, point A. What is point A? This is all review. This is stuff we've been working on already. So what rational number with a fraction is point A, there's point B, and then point C, and D, and E, and F. What are these numbers? Just write those down in here. And then for, hey, we don't want that. For number 21 right here, we see a number line. Here's -5. We don't see the 0. The 0 is way over here. Here's -5, here's -6, here's -7. What are we counting by every time we see these marks? I wonder. So where would -5.5 be? Where would -6.3 be, and so forth? And then for these down here, these are hard ones right here. So we'll do some of these right here. So A through F, comparing them. When we have a decimal number and a fraction number, or I mean a fraction decimal number here, and we're comparing them, it's easiest to change the fractions into decimal numbers. And so 1/10, that's pretty easy. It's 0.1 right here. So we want to compare decimals to decimals, and that's 0.09. So if you want to make this number all the way to the hundredths place, because this is the hundredth, now we can compare this to this, and we'll put these symbols. Remember, this symbol right here means less than, right? Because it kind of looks like an L. It's easy to kind of memorize that symbol. Whenever you see that symbol, you say the word less than. Or actually, you say the word is less than. So you would say something is less than something. And then this symbol right here, of course, is greater than. You know what? This is going to be a whole lot easier if I just type it in. That was easy. And of course, you know, equals to. So look through those, change these. Negative 2/3, I know we haven't talked about that one. You would say negative 0.6666. That's a repeating decimal. It keeps repeating. So how does that compare to negative 8? For each of these, here's a clue. Just think of a number line. Okay, and I think you could look at previous number lines. Just kind of think of a number line. Whichever number is further to the left, the numbers get lower and lower, smaller and smaller. As we move to the right, numbers get greater and greater and greater. So as you read this from left to right, you want to say 1/10 is, now is it further to the left or further to the right of 0.09? Ask yourself that question. All right, pause for a second, pause this video and do this page right here, these numbers. Okay, let's go ahead and start looking at answers here. Let me zoom out. No, we're supposed to be on that. I think I got my answers right here. Check your answers. So pause here, check all your answers and see how you did there. Okay, hopefully you did real well. When I am looking at these, I want to look at number 21 right here and just kind of go over some of the difficult areas that we see. If I pick some of these out, like B, negative 6.3, I know 0 is going to be somewhere like way down here, right? And as I count this way, when I get past negative 5, I have to know what am I counting by. And there's 10 jumps, so each of these are tenths. So this is negative 5.1, negative 5.2, negative 5.3, negative 5.4, negative 5.5. That's A, negative 5.5, and so on. So when you're moving to negative 6.3, you have to pass the negative 6. It's somewhere between negative 6 and negative 7. Okay, it's not in between negative 6 and negative 5, right? Negative 6.3 is somewhere on its way to negative 7. So that's why you'd say negative 6.1, 6.2, 6.3 right here. All right, check the rest of these. And you can pause right here and just kind of double check your answers. All right, let's get into today's lesson. Today's lesson is about absolute value. Here is a kind of a discussion introduction right here. The game 25. I just made up this game. There's no real game, but it could be a game. So Lola and Charlie are playing 25. It's a card game in which they have to add up their cards. They pick 5 cards, and then they find the total, and they end up with these 5 cards right here. Whoever is closest to 25 wins the hand. So when you score this, you score either like a plus, like if you scored like 30, you would have a plus 5. Or if you scored, your total was 22, you'd say negative 3 because you're 3 under 25. You score yourself by comparing to 25. So we have Lola here. We add that up. She scores what's her score? Now she's comparing it to 25, so she is over 25, so definitely a positive. That means over and above, and positive 5. So she scores a positive 5. She's over by 5 points. Charlie, what's his score? Yes, negative 4. He is under 25. So he's lower than 25. It's a negative number. And he is under 25 by 4 points. So who wins the game? Who is closest to 25. Yes, Charlie is the closest. And do we really care if they're over or under 25? It doesn't really matter, does it? All we care about is how far they are from 25. That is an example of absolute value. Whenever you just think about it, you're only concerned with how close you are to something. That is an absolute value. So absolute value, here's the definition right here. So write this down somewhere. Absolute value. The definition is on the next page. I think I can just kind of like right here. The distance from 0. That's it right there. So here are notes right here. You want to write these notes here. Absolute value, very simple. Just a few notes, and then we'll put some examples on here. Absolute value is the distance away from 0. So in our game of 25, we really were comparing to 25. 25 kind of was our 0. Even though it wasn't the number 0, we were thinking, here's 25 on a number line, and we were only concerned with how far above or below we were. So the distance from 0 is the absolute value. How far from 0? It's always going to be a positive number, because distance is always positive. Can't be a negative distance away from something. Now your location is negative, or positive. So here are some examples right here. So we've got sea level, ground level. Sea level and ground level are considered 0. Like if I think of a number line that is a vertical number line like this, 0 would be right there, and then other things are above and below 0. So if you're under the water or underground, you are at 0 right there. So the guy, what's he digging? Oh, there's treasure down there. The guy is 10 feet below the ground level. So he is at -10. But if we say, how far is he from ground level, we would be using absolute value. We would use these symbols here. We would say the absolute value of -10. And that's what it would look like right here. The absolute value of -10 is 10. Because we're asking how far from 0 is -10. It's 10 away, right? So it's a positive 10. And the bird right here, let's do the bird. The bird is 10 feet above the water. So how far from the water? That's the absolute value of 10. What's the absolute value of 10? How far is the bird from the water? 10. That's right. It's a positive number. They're always going to be positive. So the absolute value of a negative number is positive 10. The absolute value of a positive number is positive 10. It's always a positive distance away from 0. Like the fish right here. So the absolute value of -3 is what? Yes, positive 3. The radio tower up here, the absolute value of 12 is, yes, you guessed it, 12. That's right. So when we talk about the absolute value, we're only talking about the distance away from 0. And there's some examples in here. You can read the examples in your text. There's some practice here. I've got the practice. All the answers are right here in the notes. And so I'll include these notes in there. And also, I do want to show, let me see, this sheet right here, we will sometime work on these in class, but I'm going to show you right now. So this sheet is called Integers in Context. It's just practice with integers. Like we have Zacchaeus' score is 3 points below the class average. Here it says what integer represents the location. So this is not talking about absolute value. This is talking about the point on a number line. So anytime you see location, you're just like, where is this on a number line? 3 points below the class average. So that would be like -3 right here, not absolute value. But when they ask, what does the absolute value of -3 represent? Now you're looking for the words, the distance from 0. You're looking for that in here. So we can see that here. The distance Zacchaeus scored was from the average. Now the average is what we consider the 0. So what does 0 represent? The class average. Now I don't know what the class average was. It's not 0, but the 0 in our thinking, remember I told you this is how our brains think of things. We'll think of the class average as the 0 on a number line, and then people score above that or below that. So in this example, 0 represents the class average. And this is going to be a worksheet we work on. Oh my gosh, there's the answers down there. Yeah, this worksheet is available on Schoology, so you can work on this, and the answers are included, and check your answers. Have some integrity. Don't just cheat and just say, oh, I got it done, because then you won't really know how to do it. So anyway, that's all I got. See you guys later.